Several people have asked me how I made the windvane self-steering gear for my boat, so this video is all about it. The video will be of no interest to anyone who is not interested in building their own windvane. I built the windvane in 2012 and rather surprisingly it's still working. The video you're watching right now was taken soon after I made it in 2012. I wanted to use the windvane when day sailing single-handed. It was not intended for crossing oceans or other passages where failure of the windvane would be problematic. The windvane is a servo pendulum type. I will not explain how servo pendulum windvanes work, as there are many places where you can read about how they work. I copied the commercially made servo pendulum windvanes, mainly using materials I could buy online. Mine is primarily made from plywood, treated pine and stainless steel. The components are screwed or epoxied together. I cannot weld. If I could weld, I would have replaced the plywood with stainless steel. The stainless tubes are 3 different diameters, and the stainless T's and elbows are handrail fittings. I'll show some photos and video of the components and details later on, but first I'll show you some drawings. These are drawings which I did back in 2012. They show how the windvane is constructed, but they're not entirely accurate, so don't build from these drawings. Some of the details did have to be changed. I realise I'm showing the drawings much quicker than you can look at them, but anyone who's really interested can go back and halt the video at each drawing. This is the paddle that goes in the water on the end of the pendulum. It's made from two pieces of 12mm plywood. The vane itself is made from 4mm plywood. I also have a smaller vane made from 4mm polycarbonate, which is intended for strong winds, but I've never actually used it. To change the vanes, you have to unscrew a couple of screws and then screw on the new vane. This is the smaller polycarbonate vane for use with strong winds. This is the vane mounted in position. The horizontal bent bar is just to limit its movement. You can see the aluminium rod which drops from there down to interface with the pendulum, and the triangular object is the counterweight for that aluminium rod. Here the paddle is mounted on the end of the pendulum. It's held in place by a small bolt which goes through the paddle and the pendulum with a wing nut on the other side. You can see the ball bearing which allows the paddle to rotate within the pendulum. The pendulum is lowered on a rope into the water for use. Normally it would fall vertically into the water, but in this case it's being held to the side by tidal flow. because the boat is moored by the stern and the tide is coming past the boat, giving the same effect as the boat going backwards through the water. I'm just moving the vane by hand to show how the aluminium rod connects with the small bevel gear, which moves the big bevel gear, which rotates the paddle. This is just to show the general arrangement with the whole wind vane on view. The wind vane is attached to the boat via 3 plywood brackets, which are intended to break if a rope should get caught around the paddle. There is also one bolt near the top of the wind vane, which has to be undone to remove the wind vane. This shows the ball bearings on the spindle which holds the small bevel gear, and also the tube which holds the larger bevel gear. The strings which run to the tiller are attached partway down the pendulum. The strings have to cross over so that the string coming from the port side of the pendulum has to be connected to the starboard side of the tiller. And a snap shackle is provided to disconnect the strings, because you can't pull the pendulum out of the water for storage while the strings are still tensioned. To connect the string to the tiller, I have a line of knots on the string, and I've attached to the underside of the tiller a small bit of plywood with a notch in it. The notch is large enough to accept the string, but it won't allow the knots to pass. To connect the string onto the tiller, it's just a matter of pulling the string forward a bit and letting it go back into the notch. This shows how you change the direction in which you want to sail. By lifting the handle, it then grips the tube, and you can then rotate the tube on which the post holding the vane is mounted. Usually friction will hold it in place, but in strong winds it may be necessary to tighten a little wing nut down the side there, which increases the friction. Now, to finish off, here's a little video of the wind vane working last year, 2024.